Hi dear students. So in the last class we have discussed about the instantaneous velocity and speed. So the instantaneous velocity is the velocity at a particular time for a moving body. Okay, if an object is moving and if you are going for the velocity for a particular instant of time, okay, then that will be known as the instantaneous velocity. And as well, if you are considering the entire movement and the entire path length which is moved, and as well the time duration for that movement, and if you are taking the ratio of these two values, then you will obtain the average velocity. Okay, that is the path length covered x2 minus x1 divided by the time duration t2 minus t1, or the displacement divided by the time taken for that displacement. That is known as the average velocity. And at that time, if you are considering only a particular time or instant, and the velocity if you have measured for that particular time, then it is known as the instantaneous velocity. Now we are going to see another term, that is acceleration. Okay, so when we have discussed about the velocity, we have seen that how faster the position is changing, that can be obtained by the velocity. Okay, how faster that position it is changing, that is known as the velocity, or the velocity can express the fastness of the position changing, or the change in the position. Here the acceleration is giving us an idea how faster the velocity is changing. Okay, how faster the velocity is changing, it can be obtained by the value of acceleration. So the definition of acceleration is that the average acceleration over a time interval is defined as the change of velocity divided by the time interval. So if the velocity at a time t1 if it is v1, and the velocity at time t2 if it is v2, then the average acceleration value will be is equal to v2 minus v1, and that is equal to delta v divided by delta t, the change in velocity divided by the time interval required for that change. So delta v by delta t, it is known as the average acceleration. In that case, the velocity, average velocity, we have seen that it is equal to delta x divided by delta t, the change in position divided by the time required for that change. So here it is delta v by delta t. So we can say that the average acceleration is equal to delta x by delta t all divided by delta t, isn't it? That is delta x by delta t is a v bar. So delta x by delta t all divided by delta t will be the acceleration. Okay. So that is regarding the average acceleration. Average acceleration is denoted as a bar, and that is equal to v2 minus v1 divided by t2 minus t1, and another definition for that one, it is the average change of velocity per unit time. Okay, average change in unit the velocity per unit time is known as the acceleration, and its SI unit is given, so you should study the SI unit also, that is meter second raised to minus 2. Meter second raised to minus 2, that is the unit of acceleration. And the dimension, as we have discussed about the dimensional formulas in the chapter 2, you should know the dimension also. So here the dimension will be m raised to 0, l raised to 1, t raised to minus 2. As well in the case of velocity, it will be m raised to 0, l raised to 1, t raised to minus 1. So the SI unit of acceleration is meter second raised to minus 2. Okay, so now suppose if you are plotting a v t graph, okay, the velocity time graph, and if you are having 2 points, suppose if you are considering a point over here and another one over here, okay, so v1 and here this one will be v1 t1, and here it is v2 t2. Okay, so the slope value, slope of these two, if you are considering these 2 points, and the slope of the graph will be given with the help of this triangle. You can find the slope of the graph. So that will be is equal to v2 minus v1 divided by t2 minus t1. So we have already seen v2 minus v1 divided by t2 minus t1 is the average velocity. So we can say the slope of the velocity time graph will give you or give us the average acceleration. In the case of position time graph, the slope of position time graph was giving us the value of average velocity, whereas the velocity time graph is giving us the slope of the velocity time graph is giving us the value of average acceleration. Okay, now come to the before that, just come to that graphical representation. Okay, a particular motion is given and the acceleration time graph is given there. So you can see in the first graph, in the first section, if you are considering the origin and the first point, here it is A. So if you are considering that OA portion, the acceleration is increasing. Okay, acceleration is increasing uniformly with the increase in time. So you can say uniformly accelerated motion is there happening. Okay, a uniformly accelerated motion is happening over there in between O and A, where A and B, suppose the point over here, if we are considering this one as B, A and B, the acceleration value is getting to 0 or decreasing, isn't it? Suddenly it is it got stopped, or it stopped suddenly. That means the acceleration at the particular time 10 seconds, suddenly it is decreased to 0, and then now there is no acceleration. That means acceleration is 0 between 10 and 18. And afterwards you can see the acceleration is getting in the negative direction. Okay, acceleration is getting in the negative direction, and acceleration, the magnitude of acceleration is decreasing, a negative acceleration in the negative direction. Okay, and after a point, again 18 to 20, 18 seconds to 20 seconds if you are considering, for a particular time the acceleration value remain constant, okay, and afterwards 18 to 20 the acceleration is constant and it is equal to minus 12 meter per second square. At the time of 20 it is again getting decreased to 0. Okay, if we are considering that that sign also, then it is, we can say from minus 12 the value of acceleration is increased and it became 0. Okay, so that is the graphical representation given. So now you just come to that instantaneous acceleration. So the velocity, instantaneous velocity, is the velocity of an object for a particular time or a particular instant. Okay, for a moving object, the velocity at a particular instant or particular time, it is known as the instantaneous velocity. The same here, that is, for a moving object, the acceleration at a particular time, okay, not a time interval, at a particular time or a particular instant, is known as the instantaneous acceleration. The acceleration of an object at a particular instant of time is known as the instantaneous acceleration. Okay. Okay. So instantaneous acceleration is defined in the same way as the instantaneous velocity. That means the delta t, the time interval, is getting, or it is tending to become 0, or it is become closer to 0. The time interval is very negligible. Then the acceleration, the average acceleration value will become instantaneous acceleration. So instantaneous acceleration is defined in the same way as the instantaneous velocity, where we know that instantaneous velocity v was equal to delta limit delta t tends to 0 delta x by delta t. This was the equation for the instantaneous velocity. The same way here you can see the instantaneous acceleration a is equal to limit delta t tends to 0 delta v divided by delta t. So here the delta v and delta t values are very small, hence we can write them as a differential equation as dv by dt. So the instantaneous acceleration a is equal to dv divided by dt. So the acceleration can also be positive and negative. That means as you know, the velocity is a vector quantity. Here our acceleration is also a vector quantity. Okay, it has both the magnitude and the direction. As we are dealing with only the straight line motion, the vector notation we are not using. Instead of that, the positive and negative signs we are using. The positive signs means towards the right side, and negative sign means towards the left side. Okay, or in the positive x direction and in negative x direction. Okay, so now let us consider a body which is starting its motion at 0 second and its initial velocity was v0, and the final time, after a time t seconds, it gained a velocity of v. Okay, so you know that average acceleration will be is equal to v0, a is equal to the v2 minus v1. Here it is v and v0. So v minus v0 divided by t2 minus t1. Here the t2 value is equal to t and t1 value is equal to 0. So t minus 0. So which will be is equal to v minus v0 by t. So if you are rearranging this equation, and if you are keeping this equation as v is equal to, then you will get, that is, v is equal to in the form of v. Okay, So v is equal to v0 plus at, where v is the final velocity, v0 is the initial velocity, okay, a is the acceleration of the motion, t is the time required. So if you are having the initial velocity, acceleration and time required, so with the help of this equation you can obtain the final velocity of that body. It's actually the kinematic equation for that. It is the first kinematic equation for the uniform linear motion, or a uniform straight line, or one dimensional motion. We will discuss that one. It's already there in your syllabus, but still now you should have an idea about this one. Now consider some of the position time graphs, xt graphs. So if the graph it is curved upward, okay, if the position time graph is a curved upward graph, then that particular object is moving with a positive acceleration. Okay, if the graph it is curved upward, the position time graph, x t graph, okay, x should be in the y axis and t should be in the x axis. If such a graph is given, then should remember that it is having a positive acceleration. And if the graph it is curved downwards like this, then that position time graph, if it is curved downwards, then that motion is a negative motion is with that object is moving with a negative acceleration. Okay, if the position time graph is a straight line, that is a uniform motion, if it is, then a is equal to 0. Uniform motion means the velocity is uniformly increasing, then the acceleration is equal to 0. Okay, the acceleration value will be is equal to 0. Acceleration is actually the change in velocity per unit time. The velocity is actually the change in position per unit time. Okay, so now if you are given with a velocity time graph, okay, a velocity time graph, if it is given, you know that slope of the position time graph is the slope of the position time graph, if it is velocity. So if it is a velocity time graph is given, so the area under the velocity time graph gives you the displacement happened. Okay, suppose if you are considering a time t1 over here, then you should find the velocity, the appropriate velocity for that value, and should find the area of this triangle under the graph. Okay, then if you are finding the area of this triangle, then you will get the displacement, the total displacement happened during this time interval t1. Okay, so remember that the velocity, the area under the velocity time graphs gives you the displacement, as well the area under the acceleration time graph gives you the velocity. Okay, remember these things, and the remaining we will discuss in the coming lectures. Okay, so thank you very much, and I think you understood the things, and just try to take down the write down the notes also. Okay, I will send you the PDF, and you do that one also, and go through the textbook. That is the necessary the important thing. You should go through the textbook very well. Okay, then thank you very much.